This video is going to explain the idea of relative dating in rocks. We're going to put on our investigator hats. So if you think about a crime scene, when you're a crime scene investigator, you have to look for clues to try to figure out what happened before you got there, and ideally what order things happened. And so you can look for fingerprints or other things to kind of give you clues. And in rocks, there are clues to tell you what happened, because many of the things that we're looking for, humans were not around to experience or see or track or record what had happened in the past. Assuming I didn't change the order, the black line would be occurring first because it is on the bottom. Then the blue box because it's over the black line but under the teal, pink, and yellow. Third would be the teal circle because again it's over the black line and the blue box but under the pink. Then the pink because it's over the teal but under the yellow. And lastly, the yellow pentagon because it is the item that is on the top. You'll notice in this example that no actual age of any of these shapes was given. We can just look at the order that they occurred in. So we know what happened first and second and which one was the oldest comparatively, but we can't put an actual age or date of when these shapes were added. We call this relative dating, where we determine whether an object or its events is older or younger to the other objects or events in the area. The principle of superposition is super important when relative dating. This tells us that the oldest objects or rocks are on the bottom, while the youngest layers are on the top. Think of it like a stack of pancakes. When you take pancakes off the griddle, you will add the first one that came off the pancake griddle to your plate. As you cook more pancakes, you will eventually stack them on top of the pancake that was already there. The oldest pancake, or the pancake that occurred first, was the one that is on the bottom, and the newest or youngest pancake is on the top. This is an example of the principle of superposition. In the previous example, the order was very obvious. It went from the bottom to the top, and that was all that there was. We also have the law of cross-cutting relations, and this has to do when other events happen to rocks that are already in place. You'll notice in this image that there is an intrusion that is moving its way up through a formation of rock. An intrusion is intrusive igneous rock that burns its way up through existing rock. Because the rock is the same on both sides of the intrusion, we know that the reddish rock had to be there first, and then the magma burnt its way up through, creating the intrusion. So if we're trying to put these in relative age, we know that the red rock was first, and then the black intrusion came second. Another feature that can occur is a fault. A fault happens during an earthquake where the earth shifts and the layers get rearranged. So if you look in this example, you can see that the black line that's on the left-hand side also runs across the middle of the image, but the rock layers have shifted. In this case, we know that these layers that are black had to be there first before the fault occurred. Faults and intrusions are always younger than the rocks that they cut across. Finally, as you can see in this image, the rock layers have been folded as a mountain was formed. It also had some erosion that occurred at the top, which is why you can no longer see the full extent of the fold. That is considered an unconformity. The folds always have to happen after the rocks were already layered. So we assume as geologists that rocks are layered in a flat pattern And then any folding or tilting that occurred happened after the rocks were there in a moment of geological uplift. Again, this whole idea of relative dating is explaining how rocks, the age of rocks based upon the other rocks that are in the area and the events that occurred in the area. It does not ever give a specific numerical age for any rock.